Hi again, I'm Carlos Cortez, AWS Community Hero. I'm here to teach you a little bit in your journey to become a data scientist using Sagemaker, or maybe machine learning engineer using the AWS services related to machine learning and artificial intelligence. So in this part, we're going to just perform coding as I told you before and start working with Sagemaker notebooks. So what about if we can just look a little bit of what we can build now. So in this part, with this section 2, what we are going to do is a little workshop using Sagemaker with NNIST dataset. So we're going to perform some data splitting. So we're going to get insights about our data, and also we're going to train our model to create Sagemaker endpoints to know a little bit more about how to create processing jobs, to create training jobs, and more. So after that, we're going to just check if our train is evaluated nice, or our predictions are becoming with a lot of failures or not, creating a confusion matrix. And then you can reuse, and then we have to also think about our building. Also, we're going to check a lot about of what happened to the building inside Sagemaker and clean up our services at the end. So further no more, let's start with the session. Okay, so we are here in the notebook. This is the last part of the session, so be careful of what Python SDK for Sagemaker you are using. Exactly, I'm using the version 2.46.0 because there are a lot of issues if you're not using the latest version. For example, if you, maybe a problem with your execution role in Sagemaker where you call, and I'm going to show you exactly what is the part exactly. But here, for example, we are exporting a serialized model in Pickle, a Python model for MNIST, is from handwriting letters. So it's a classic ML model to classify and to detect what is the number reading in your handwriting image. So let's go. We're using Pickle because we are using a serialized Pickle model here, and that is gzip, also gzip, and we're going to request the pre-trained model from the the dataset here, and all the images here from the URL. Be careful with, because after this I was checking the original URL is not working, that from the learning.net, so I'm gonna change this. So be careful and make sure you are arriving. You can get this to this URL. So after that, we download the image, and we can see here what is the amount of image we have here. Let's explore this a little bit. We press Ctrl plus Enter at the same time to execute the cell only, but you can just, in the run menu, you can just run all above selected cells, run all cells, or whatever you want to do in order that you want to execute as many times as you want each cell. So we can check that this pre-training model, that this is 5 and 0, 4, 1, 9, 2, and etc. etc. We have a lot of images with different kind of handwriting for every letter or every number, and we are performing the training that way. So after that, we're going to transform and train dataset and allow to S3. So for example, here we are using, that is the part where I told you that be careful with the Sagemaker SDK version that you're using in Python. Because this guide execution role, if you're not using the last version of, for example, a version superior than the 2.45.x, so you have to use a later version than that. If you do not do that, you're going to raise an error here about you're not obtaining and getting the role correctly. So start your body session, because we are going to use a lot of Python SDK Sagemaker. We need body tree for S3 also. Define our bucket and our prefix to our subfolders inside the S3 bucket, and perform some kind of stuff to partition our our data in the train, validation, and test in three parts. As we can see, we also mainly by default we split our data into train and validation, or train and test, but in this time we're going to train, validate, and test, because we are train and validate, and the last part we're going to test. This is a good approach also, but it's in your hands to decide whether you want to split your data into in 20/80, in 70/30, in 70/20/10. So that is that approach that you have to decide as data scientist, as data engineer, as part of your project, as what kind of data you're using, what is your the cycle of your project, the steps that you're taking, and how much data you have. So what is the amount of data you have is going to be important to decide if you want to split it in 2 and 3. I mean, 2 is very useful. 3 is just to make sure everything's correct with one additional step for testing, but it's okay. So after doing that, we're going to just save our data as in format .ssv, and write all this in our AWS bucket, AWS S3 bucket, as a data.scv. So that we just to check everything's going to be okay, executing this, and the output here is yeah, let's wait. Yeah, we have to wait a little bit until this is completed. It's going to take a little time. So after that, where's a little bit code to save our S3 model, our S3 data in the format of .csv inside S3, and start doing a lot of actions from S3. For example, for training our model, we have to first import the Sagemaker Python library here, and the estimator that is going to be the important library to execute our model, and define our container that we're going to use. In this case, we're going to use XGBoost. So we're going to get the container from the built algorithm that AWS provides for us, and it's XGBoost built from scratch by the AWS inside. So after that, we're going to just check and validate our S3 information and get all the data from the dataset that we saved before in S3 in train, validate, and in our S3 buckets, and then create an estimator. So we use the estimator function here to pass container, the AWS role from Sagemaker, the kind of AWS EC2 instance that's going to be processing this job, and the output location also. Okay, so after we do that kind of estimator, we also have to set our hybrid parameters for XGBoost. So we have this by default defined by Sagemaker, but we can just change these variables and make another Sagemaker training for automatic auto parameter tuning job. But first here we're going to just set by default the max depth in 5, the gamma, eta, and signing objective in number class and number around here. So for example, we're using the function objective here, the multis of max, and then we create our training channels for both to train and validations. So the train channels are going to be our Sagemaker train data variable and the validation data variable that we created before. And the last step is train the model. So as you can see, it's as fast as one line of code to train our model. After we set the variables for hyperparameter tuning, we set the estimator for defining what kind of container we're going to run here and what kind of estimator we're going to go. It's like if you want to train something, you got to tell in which container you're going to use, what kind of machine or EC2 instance you're going to use, and what is the output what is the input and the outputs, and what is the session of the both tree and Sagemaker and S3 also. After you define all this, you can just in one line of code use the fit function and input all data channels. It's going to pass to the variable of to the SDK, the train channel, the validation channel, the data channels, and please log everything here when we run the model. So if we run the model here, we're ready. So it's going to be just going to wait a lot of minutes, like 5 minutes, and after that we can just with a line of code, so with the deployment command here. So the deployment is related to the Sagemaker endpoint. So we're just creating here a Sagemaker endpoint from using the Python SDK in Sagemaker. So we initialize our input with one instance. It's going to be CSV because we're going to pass all the input variables to our future predictions with format of CSV. And we're going to use Sagemaker inference endpoint with the size of the T2 medium. It's going to be smaller, but costly and effective because we are just testing. And we have here just check the data if everything is correct by data by our model. Sending download this from a string to validate that our model is correctly making predictions, and then we're going to check a few registers from that string to perform some predictions with our third split, because you remember we split our data in the making the train split, then the validation, and the third one was the test. So we're going to just make sure the S3 bucket with the third data set that we split here, that is the test data, and make a little validation of our data and what is the correct or incorrect answers that we can predict with this new model. Okay, so for the last part, I promise you guys to update the Sagemaker notebook that we review in the last minutes with the AWS Sagemaker SDK 2.x. So there are a few changes, and there's a new demo also that I want to just show you about how to run all the cells that we review in these last minutes. So let's check on the console with the updated version, and also I just uploaded to a public repository in S3 to you guys to replicate them also with me. So let's go to the AWS console right now and let's check it out what I have for you. So this is a new version, modified version, for the AWS samples for the with the AWS documentation. I have a few changes. First of all, as I told you before, you have to update the Sagemaker also. And let's go straight to the code. A few changes here. I'm just writing I just download the S3 bucket files and the MNIST images model and all the dataset to another bucket that is located here. And I'm using the default bucket as my output bucket for my model. That is the one generated by the Sagemaker Studio itself. So let's straight to the code right here. This also the same code as the other one. Structure the data. There's a lot of functions here. For example, the get dataset from the S3, to upload the S3 function here. Once the data is partitioned in three parts, as we are mentioning here during the presentation, and convert and transform the dataset that we have. So we are going to test the validation, split, the test, and the training. Yeah, I raised the part of the training because they had me a little problems with the time that is processing the training dataset. So I did it in two parts. First, training part, and once it complete, I changed to validation test, and I have here all the examples and datasets validated, split, and uploaded ready in S3. So you can check it out. You can test yourself. You can change whatever you want here in this line of partitions, because it's all about these functions at the end of the day. So let's train the XGBoost model here. So I already ran the cells here, but for example, for the Sagemaker new version of the SDK, we're not you wouldn't have the get image URI all. Sagemaker replaced that function for the new one, that we have to import these Sagemaker image URIs, new kind of import the latest image from Sagemaker and the building algorithm that Ableist have. So we're using the XGBoost newest version and number 1, and we're gonna set that different from the other example, all this JSON with a lot of parameters that is going to be what is the algorithm that we're going to use, the training image that we're going to use, for example. There is some I think it's more easy to replace those variables and to train your model. So role array in and hyperburn tuning also inside these configurations. So these training parameters, another important things, this channel name and the data source also, to set our S3 outputs and where it's going to take all the data, for example, and the content type and compression type also. So if we focus on training on different and distributed computing, there's another example about that, but we are going to take the path of doing in a single machine job. So we are defining our single machine job here, just the name, and start configuring our job to be submitted. So once it's ready, once it's ready and to configure our single machine job here, we're going to be initializing our S3 bottle session, create the training job, and let's monitor our training job and what is happening to our training job. So if we go back to Sagemaker console and we go to training jobs here in the training slide here, in the sidebar here, we're going to see that this kind of experiment here is running. It's completed right now, but it's 3 minutes. It's not so, it's not so long. Let's check it out what it have inside. So you can see the training time, the billable time. That is some important parameters here. Check if you are just monitoring the billing of the Ableist console. Check it out. If it's something, if you can find some error in timing out or something, you can check here. And the IRL, and well, the instance type that we are using, a very big instance type, 10x large. You can change that in the training parameters that we just checking. If you change that, it's gonna be here. In the common training parameters in resource config, you can change the training tab, but I do not recommend to change it because it's going to be faster if you use a larger S2 instance, but it's going to be just 77 seconds of computing. So think about that. There's something to think about it, that you can change to review if it takes longer or not to compute all the processing. So let's continue here. And well, let's submit our training job. We are using a lot of SDK here of Sagemaker. For example, create training job, describe training job to check if it's in progress or not, and wait until it gets it is not in progress anymore. So after the job is finished, let's confirm if it's finished or not. So the current training job is going to be the training job status completed. So after the training is completed, we have to just deploy our model, and after that we're going to change. We're going to see a little bit metrics and other stuff. So to host our model, we have to just get out of the using the Sagemaker SDK also. So we're going to register our model you know, and then we're going to create an endpoint. So that's the thing that we're going to do right now. So describing the model also, and we are going to create a model, you know, create a model with the model that we have right now, train it. So after that, we're going to create a model endpoint configuration. So the endpoint configuration is going to be used for future predictions. So it's going to be very important to first determine all the parameters in your endpoint configuration, and then you create the endpoint. It's going to take a little longer. So that's this code for your configuration for the endpoint, and you pass all these variables that are important. For example, the instance type that your model is going to perform predictions. So this is important for production workloads. You're going to need larger instances if you want to perform faster predictions in real time, or you're going to be your prediction is going to be on batch. Well, you can think about it, what kind of instance you would like to use on production. So we're going to use an autoscale of 1. We're starting with 1 instance, and the model name is going to be inserted here. Okay, so I think it's ready. So the rest of the code is creating the endpoint. You know, we're going to do the endpoint here and just wait it from the creating is completed. You can check also in the Sagemaker console right here in an inference separate part here. You have the models. This is the model deployed. So I'm using this model for creating an endpoint configuration. After I create an endpoint configuration right here, I create an endpoint, an inference endpoint at the end of the day. So this is going to take like 10 minutes, 5 to 10 minutes. Yeah, regarding of whatever you are, what be your model is, but no problem. Yeah, let's wait a little bit after your endpoint is in service, and after that we're going to just test it. So to validate the model for the use, we're going to create a runtime here in Sagemaker in order to evaluate our model. So and test a little bit with that. So I'm going to load here a part of our dataset that we are. Remember that we have 3 parts: training, validating, and testing. The third part is for this. You know, the first 2 parts for training and evaluating our metrics pre-training and during the training, but this one is post-production or post-deployment. Okay, so let's start here by predicting a label and see what happened and what the accuracy and all the confusion metrics here. So the predicted label, for example, with this little dataset is 7. I'm just randoming whatever a predicted label is. Okay, so if we want to see more predictions, this code is going to help to. Yeah, this code is going to help how good our predictions are, evaluating the accuracy and evaluating the error rate on the dataset here. So for example, the error rate here is 11%, for example. And if we make some predictions here, I just put 20 to predict what happened to if I put 20 predictions at the same time. And let's see the labels. Okay, we have the labels and we have the predictions, so we can just start working on creating our confusion matrix. So if we create our confusion matrix here, let's see if we can do this right now, and visualize how good our model is in this confusion matrix with all the classifications, multiple classification labels that we have in our model. Every number here is the actual value of the letter. As I told you, this dataset right here of numbers, no handwriting numbers, and we have to predict which number it is. So we have few errors, and most of the time we see actual. For example, this is the 0 and we are predicting 180 and 170 here, and we can see all the predictions labels here, no? And for example, it's not all good, because for example, if for the 0 we are just confusing number 3, number 4, number 5, number 7, the predicted is 0, but maybe, and the actual number is 0, but maybe number 3 is predicted but actually is 0. So we have some errors. There's nothing to worry about. This is a model. This is not going to be 99% accuracy, because when we have 99% accuracy or 100% accuracy, most of the time the model is overtrained, no? And it's something, is a word in machine learning called overfitting. So overfitting our model is to train it very, very perfectly, that we actually only know very well the numbers or whatever knowledge we have in our dataset. So if we put something different in real life, maybe our model is not going to interpret. It's going to be ready to interpret different kind of things. They are 100% accuracy in whatever they learn. So it is important to always check to errors, and to our model is not always going to be perfect. So that's the real thing when we're involving machine learning. We're just trying to figure it out, how to enhance our accuracy, how to increase the metrics to be close to 100, but not exactly to 100, not exactly to overtrain. So I hope you enjoy these sessions. Don't forget to delete all the endpoints, because the endpoints is going to be very expensive if you just don't delete them. So after these sessions, please delete the endpoints, okay? And I hope you can just start working in machine learning with this kind of model and with Sagemaker. Now, Sagemaker have a lot of different algorithms, different awesome stuff that you can start your journey to data scientist, data engineer, or wherever in the great world of artificial intelligence you are. So don't forget to connect with me. I'm Carlos Cortez, a Bliss community hero. Please visit my website also, and well, see you later. Bye bye.